Just in the last class, I have given the side headings of this chapter about the subtopics of this chapter. What are the subtopics are there of the first chapter, and about the complete info about the chemistry. What are the 5 different topics are there about the chemistry in the class 10th that I have explained, along with the subtopics we started in the last class. In that, first we studied about only about the physical change and the chemical change we have did in the last class, right? So about the
Yes.
photosynthesis equation we have done and the respiration equation we have done. In the last, we have done the small introduction about the endothermic and the exothermic. But before that, starting of the class, can you hear my voice properly?
Yes.
Yes, sir.
Yes, sir.
There's no breaking and all, right?
Yes, sir.
Yeah. Quickly, any one of you can you tell me the examples, whatever the homework I have given for you in the last class?
So about physical and chemical reactions, sir.
And about the physical change and the chemical change.
Sir, respiration.
Respiration. No, I asked you some common examples in your surroundings, right? About the physical change and the chemical change.
Yeah, sir, examples only. Respiration comes under chemical change, right, sir?
Yeah, respiration comes under the chemical change only.
Yeah, so that's what it is.
Okay. Next, anybody want to give the new
Physical
example?
change can be folding a piece of paper.
Sir, cooking food, like it's a chemical change.
Sorry, can you repeat again?
Sir, cooking food.
Food is a chemical change. Good. Next. That's all.
Breaking a glass.
Breaking up the glass. Okay, tell me now. Breaking up the glass is a physical change, reversible process, or the irreversible process?
So it's an irreversible physical change.
Irreversible.
Physical change.
It is an irreversible physical change. Okay. So today we'll start with the chemical reaction. Everybody knows what is the definition of chemical reaction, right?
Yes, sir.
Yes, sir.
Yes, sir.
So chemical reaction is nothing but the reaction between the 2 or more elements, and which will form always the new products. So the process involving the chemical change is called as a chemical reaction. The process which involving of the chemical change is called as chemical reactions. So if you take any example, like CaO plus CO2, what you'll get? CaO plus Cl2, what you'll get?
Calcium carbonate.
Calcium carbonate.
The CaCO3.
Okay, so these are the reactants, and right side of the arrow is called as an
Product.
okay. So there's a simple chemical reaction. So whatever the process involving a chemical change, that is called as a chemical reaction. If you are writing the chemical reaction in the symbolic format, like with the help of the chemical formulas, that is only called as a chemical equation. Yes or no?
Yes, sir.
Yes, sir.
If you write in the words like calcium oxide reacting with the carbon dioxide, it is called as calcium carbonate, which will use calcium carbonate. That is the chemical reaction. But you are writing the given reaction in terms of symbols like formulas or the element symbols and all. That is only the chemical equation. So left side part will be the reactants. So what will happen on the reactants usually? Whether a bond will be formed or a bond will be broken.
Sir, new bonds will be formed.
Bond will be broken on the chemical reactant side. Okay, suppose CaO is there. Ca and O will have the 2 different elements, right? We break into the Ca plus O. So the bond between these 2 elements will break. So breaking will happen in the case of reactant side. What about the product side?
Sir, new bonds will be formed.
Will be formed on the product side. Good. Now, if it is only one direction arrow is there, that is a irreversible chemical change. Yes or no? Irreversible reaction.
Yes, sir.
If two are there now,
Sir, reversible.
reversible reaction. Like if you take the example, N2 plus 3H2 so gives 2NH3, right? So this is example for the reversible chemical reaction. Okay, any doubts in this?
No, sir.
No doubt, sir.
Okay. Now third one we'll take here. Mg plus O2 will give rise to what you will get from Mg plus O2?
Magnesium oxide.
Magnesium.
Sir, MgO.
Is it the balanced one?
No, sir.
No, sir.
No, sir.
All right, because we have the two oxygens on the reactant side and one oxygen on the product side. So it is a not
Mg, sir.
balanced chemical reaction. So to balance this one, what you'll do, you'll keep two on before
2 and
magnesium
Mg.
and 2 and Mg here. Now it is a balanced
sir.
chemical reaction. Fine. So if you see the textbook, NCERT textbook, this is the first diagram will be there in the textbook, right? So burning of magnesium ribbon in the presence of air will form the magnesium oxide in the form of ash. But here one question arises. Why we need to clean the magnesium ribbon before starting up the combustion process?
Sir,
To remove the oxidized layer.
Why we need to remove the
sir,
yeah.
Because it is highly reactive with oxygen.
sir, Manoj sir is wanting you to respond in the WhatsApp, sir.
Just wait a minute, sorry. Okay, thank you. Okay.
Sir?
Yeah.
So once can you scroll up, sir, down?
Okay.
So there you have written like irreversible and reversible reactions. Also. Once can you explain that?
Okay. See, if you take the chemical reactions, there are the two types of chemical reactions will be there. One is
Yes.
the irreversible chemical reaction. The next one is a reversible chemical reaction.
Yes, sir.
Okay. Irreversible chemical reaction means what? The reactants will convert into the products. That is only one way. Okay.
Okay. Yes, sir.
But if you take the reversible chemical reactions, these are the two-way reaction.
Okay, so like arrow marks, can you explain that?
Yeah. So if you take the irreversible chemical reaction, we have the only single arrow will be there like this. Only one directional arrow will be there. Okay, that is the irreversible. But a reversible
Yes,
chemical reaction, we have this is the one direction, this is another direction. Like two off-headed arrows will be there. That is a reversible chemical reaction.
yes. So but why?
That is a two ways, right? Suppose if you take this NH3 equation part, whenever the concentration of nitrogen and the hydrogen is higher, the reaction will goes towards the NH3 formation. Okay.
Yes, sir.
But once enough concentration is formed here on the product side, the reaction may go reverse also again under the different conditions. Again, NH3 will decompose to form N2 and the 3H2. So it is a two-way reaction.
Okay, sir.
Understanding? It may
Yes,
go
sir.
from left to right or right to left. That is what the meaning of reversible chemical reactions.
Yes, sir.
Clear now?
Yes, sir. It's clear.
Okay. So next one we are discussing about this, right? So 2 Mg plus O2 to form 2 MgO. Okay. Everyone join the class.
Yes, sir.
Maybe one or two didn't join, I think so. Okay. So in the first page of the NCERT textbook, you have this equation part. Magnesium ribbon burning in the presence of air to form magnesium oxide. But before starting of the combustion process, we have to clean the magnesium ribbon with the sandpaper. What is the main reason?
Sir, because the oxidized layer speeds up the burning.
So the
Very-
magnesium oxide and magnesium carbonate covers up the ribbon.
Very good. Suppose magnesium is the most active metal. Okay, it is called as an active metal. When you take the magnesium ribbon in the outside atmosphere, so if you have taken the magnesium ribbon like this in the outside atmosphere, whatever the oxygen is there in the atmosphere, it will react with the magnesium and will form the magnesium oxide layer. Okay, so a thin layer will be formed on the surface of the magnesium. So what this magnesium oxide layer will do, it will not allow the magnesium to react properly with the oxygen. Yes or no? In the combustion process. Understanding?
Yes.
Yes, sir.
Okay. So before starting the combustion process, if you remove this magnesium oxide layer, thin layer, then the combustion process will be efficient. We'll get the sufficient amount of the magnesium oxide. That is the main reason. So to remove this magnesium oxide layer only, we'll generally rub the magnesium ribbon with the sandpaper. Okay. So it is also a chemical change. So there are the small examples, but the important topic will start here. How can we identify whether the given change is the chemical change or the physical change? How can we identify?
By chemical equations or formation?
So we can say whether the given reaction is a chemical change or not. Now, with the help of these 5 points, you can identify.
Yeah, sir. Okay. Okay. Change in
Change in state,
color,
change in
change,
color,
change in temperature,
Change in state.
formation of precipitate, and evolution of gas.
evolution of the gas. Good. So characteristics of the chemical reactions are what? First one, change in
State.
state. That means whenever the chemical changes happen, sometimes the reactant will be in the different state and the product will also form the different state. So with the help of this, you can say the given change is the chemical change. Like if you take example, 2H2 in the gaseous state plus O2 in the gaseous state, it will form the 2H2O. But H2O is in the liquid state, right?
Yes, sir.
So whenever the mixture of the hydrogen gas and the oxygen gas, it will form the water in the liquid state. So complete state changes happen. In the reactant side, completely two are gaseous state. In the product side, one is a liquid state. So with the help of this, you can say that the given reaction is a chemical reaction. Understand?
Yes.
Okay. The next one is a change in color. Now tell me how to change in color will happen. Change in color.
Rusting of iron, sir.
Rusting of iron. Very good. Can anyone of you tell me what is the equation part?
So like it is iron Fe plus
Fe
O-
plus
O2 plus H2O.
O2 plus H2O is equal to FeSO4.
H2 is equal to Fe2O3
Fe2.
Fe2O3
plus
Okay.
O2
Plus
plus H2O plus H2O. Sorry, sir. H2O.
I have doubt.
Yeah.
Sir, what is the G in the first one? Sir, G, and L. What is that, sir?
Okay. So S indicates the solid state in the bracket. L indicates the liquid state.
Yes, sir. Understood.
G indicates the gaseous state. Now, and AQ also will be there. There is the aqueous. Okay.
Yes,
And so
yes.
what about vapor? Like V is vapor, right?
Vapor is a gaseous state only we'll mention, right?
Acha, okay, sir.
Vapor will mention in the gaseous state only. But we have the last one more thing is there, precipitate,
Downward arrow.
PPT. That is a downward arrow. Good. Gaseous state is a upward arrow. So now we have taken the hydrogen gas that is in the gaseous state. That means oxygen gas that is also in the gaseous state, and the water that is in the liquid state. Clear?
Yes, sir.
Okay. Now
Yes.
tell me, what is the change in color?
So like the
Sir, okay, sorry.
iron oxide is in red color, reddish brown.
Reddish brown. Okay. Is it the balanced equation?
No, sir.
Then balance.
The balancing will come to know after this session.
So
Directly.
2 Fe. So it will be 2 Fe, 3 O.
Okay. 3O.
2 Fe.
How come?
So forms 2Fe,
Only 2 Fe, sir.
2O3.
Only 2 Fe.
No.
So
This is
2Fe
actually
is, yeah.
this is actually the balanced equation now. I will teach you how to balance this afterwards.
After this characteristics.
Yeah, after the characteristics only we'll come to the topic hit and trial method. And along with that method also afterwards I will teach you the direct balancing and the algebraic method. Okay. So
Yes.
change in the color is what? Initially the reactants will be in the one color, but after the chemical reaction is happening, the product will form the different color. So with the help of the color identification only, we can say the given change is a chemical change. Like if you take common example in the laboratory,
The copper sulfate plus zinc granules.
yeah, that is also you can do. Copper sulfate plus in the laboratory you have to do as a iron nails will take. So it will form
Iron sulfate
iron sulfate FeSO4 plus
copper.
U. So generally copper sulfate is a which color?
Perfect blue.
Blue color. Okay. What about the iron sulfate? Ferrous sulfate?
Pale green. Pale green.
Pale green color. So when you take the iron in the copper sulfate solution, they will undergo the chemical reaction and it will change into the ferrous sulfate and the copper. Now color changes happen, right? From blue color to the pale green. Okay. So this is only the change in the color.
Sir, I want to give an example. You can say that that is input also the changing color will be.
Okay. Give me an example.
Sir, lead nitrate plus potassium iodide.
Lead nitrate. Can you tell me the formula along with the formula?
PbNO3 2 plus Ki
Okay, good.
is equal to PBI
PBO or PBI?
PBI2. Support lead iodide.
Okay, okay, wait a minute. Okay, you are taking the PBI too, okay?
Plus KNO3. KNO3.
Okay, okay.
So it is even a precipitation reaction.
Yeah, this is a precipitate reaction.
It is in the formation of precipitate.
Yeah, actually,
PBI
in the formation of precipitate, but in this,
I got this doubt in my school, but my teacher told that, but they are colorless. We can take this as example, but I did not still, whereas I did not understand still.
okay. Suppose you have taken this lead nitrate and this part Ki, potassium iodide. Okay. Generally, if you take this lead nitrate, right, these are actually reddish color.
Okay.
Okay, 1 minute.
Okay, sir.
Lead nitrate is not either reddish color, I think so. It's a colorless only.
As my teacher told, the colorless and potassium iodide is
Yellow color. No. Potassium iodide is yellow color.
yellow color. Okay.
It's a yellow color precipitate will form here.
Okay.
This is a colorless only mostly.
Okay.
I'll confirm and tell you, but this is a colorless. Potassium iodide is pakka yellow color only.
Okay.
When these two undergoes a chemical reaction, actually these two is in the aqueous state only. Aqueous means what? Liquid format.
Liquid form.
Okay. Now you have taken one beaker here. One more beaker you have
Yeah,
taken. So initially we have it here the PbNO3 taken twice.
Yeah.
In that you have taken about the potassium iodide. What will happen? These two will mix, right?
Yes, yes.
But at the end of the chemical reaction, some precipitate formation will happen like this. Sorry, I'll write it other way. So at the end of the chemical reaction, some precipitate will form at the bottom of the beaker. That is only the PbI2, which is yellow color.
Okay, sir.
Understanding? So it is also example for the precipitate reaction. Clear now?
Yes, sir.
So this is also precipitate. Precipitate means what? Nothing but solid only, right?
Insoluble solid.
Solid. Insoluble
Insoluble.
solid in the given liquid, or you can say. Okay.
Yes, sir.
Okay. So above I am writing one example like when you are heating the lead nitrate. So lead oxide. It will form lead monoxide plus oxygen gas. So this is a solid and this is 6PO2. Then this will show the yellow color. But this lead oxide is in the red color. So this is also example for the color change. Okay. What is this triangle indicates? What is this triangle meaning?
Heat.
Applying heat.
Applying the heat. Okay. So any doubts in the color change characteristics?
No, sir.
Okay. So next one we'll go for the evolution of the gas. It's very, very important and one of the most common characteristics of the chemical reaction. So same, we'll take one.
Like reaction of metal with acids.
Very good. If you take the zinc and if you dip it in the, if you add in the hydrochloric acid, what will happen?
Zinc chloride plus hydrogen gas.
Zinc chloride plus hydrogen gas formation will be done. So this is a solid, this is the aqueous, this is the aqueous, and this is the gaseous state. Okay. So whenever the chemical changes happened, some gas will release. With the help of that, we can say it is a chemical change. But how to test this hydrogen gas?
So it burns the matchstick with a pop sound.
Very good. So what is the test for the hydrogen gas?
So the matchstick, taking a burning matchstick, or we can even use a balloon.
Like burns with a pop sound.
Okay. Bring the matchstick near to the test tube of the hydrogen gas. Sorry, bring the matchstick near the test tube, which evolves hydrogen gas. Now, what sound you'll get?
Pop.
Pop sound.
Pop sound you will get. So when it gives the pop sound, now we can confirm that whatever the gas evolved from the test tube is the hydrogen gas. Okay.
Yes, sir.
Yes, sir.
So this is a simple evolution of the gas. So next we will go for the.
Now can you scroll up?
Yeah. So next we'll go for the change in temperature. This is the important topic. That's what we discussed in the last class, right? Endothermic and exothermic.
Yes, a change in temperature.
To change in the temperature. So whenever the chemical reaction is happened, either the temperature will increase after the chemical reaction or the temperature will decrease. Two options will be formed. Okay.
Yes, sir.
So reaction which results in rise of temperature is called as an exothermic reaction. What is the meaning of exothermic?
Releasing heat.
Releasing of
Releasing heat, sir.
temperature.
Chemical reaction which results in the rise of temperature. Can you understand the handwriting?
Yes, sir.
Yes, sir.
Which results, sorry, in rise of
Temperature.
temperature. A simple is what? heat released during the chemical reaction, right?
Yes, sir.
That is a exothermic reaction. Any examples?
So like lime water plus water is equal to slate lime plus heat.
Okay, we can say example like dilution of an acid or base. Dilution of acid or base is an exothermic reaction. Understanding? Suppose when you're adding the acid to the water or the base to the water, it will always release a large amount of heat. So it always comes under the exothermic reaction. First one. Second one, respiration. What is the equation part for respiration?
So see, glucose
Glucose
plus oxygen
plus oxygen.
gives
Forms
CO2.
carbon dioxide and water, sir.
Carbon dioxide and the water. Sorry.
And sir, also ATP is released, like energy is released, ATP.
Whatever the energy releasing, it will happen in the form of ATP only. It will release. Good. So respiration is clear. Still, anybody has the doubt now, you can ask me, because in the last class itself we discussed about the respiration. Exactly opposite of photosynthesis. Just if you remember the photosynthesis equation, now just exactly do the opposite process. That is only the respiration equation, right?
Yes.
But
Yes, sir.
in the previous board exams, they given one example of the an exothermic process. Decomposition of vegetable matter. Generally, if you take the decomposition process, it is the endothermic process, right?
Yes, sir.
Decomposition process means what? We are giving the heat, or we are giving the energy in the form of heat or the light or the electrical current. Yes or no? So it will comes under the endothermic, but decomposition of vegetable matter by the bacteria is an exothermic process. So this is what the example they asked previously in the MCQ paper in the term 1 this year, and the previous in the board exam also they asked it. So whenever you see the decomposition of vegetable matter, don't go for the endothermic. It is an exothermic process only.
Okay, sir.
Okay, but why? Why? Because
Sir, is it because since bacteria are working to decompose the substance, maybe the energy or released from them
very good.
or released by them?
Exactly. So bacteria is decomposing the vegetable matter, right? So bacteria will absorb some energy, but overall energy it will release. It will release a lot of heat energy during the decomposition process, but overall will be the exothermic. Yes or no? Suppose if you take the
Yes.
example like burning of the coal. Initially we have to ignite the coal, right? With some energy.
Yes, sir.
But once it start ignited, we don't want to give any heat energy. It will produce the heat energy more than what we have given. Yes or no?
Yes, sir.
That means whether we can say the burning of the coal is the exothermic or endothermic.
Exothermic.
Exothermic. Why?
Exothermic.
The
Sir, but
overall
initially
energy.
we gave energy to coal, right?
Yeah.
Initially we gave energy.
Yeah, that is what I'm telling. Initially we have given only 10 kilojoules of energy, but after the burning process, it is giving 100 kilojoules of energy. Now, can you tell me overall what is happening? 100
both
minus 10.
90
90.
kilojoules
90 is releasing or absorbing?
released.
Releasing.
Releasing, sir.
Releasing means exothermic only, right?
Yes, sir.
Clear?
Yes,
Kavya?
sir. Yes, sir.
The same way, decomposition of vegetable matter also same. Overall, it will release the energy. So it is an exothermic process.
Yes.
Fine. Any more doubts?
No doubt, sir.
Okay. Next, combustion process are always exothermic only. Everyone knows what is a combustion. No, I don't know. What is the meaning of combustion?
So photosynthesis for endothermic.
What is the meaning of combustion reactions?
Sir,
So like
using
reacting with
oxygen for
oxygen.
burning.
Usage of
Oxygen burning.
Reaction with oxygen.
Generally, we will burn the substance in the presence of oxygen to obtain the energy, right?
Yes, sir.
That is only the combustion reactions. So always the combustion reactions are the exothermic reactions. Always particular fuel will have the calorific value. If you take petrol, it will have the different calorific value. Calorific value means what? The amount of heat energy it will release after burning 1 kg of the substance in the presence of oxygen. Yes or no?
Yes, sir.
Yes, sir.
So all the combustion reactions are the exothermic. Fine. Next we'll go for the endothermic. Now what is the meaning of endothermic?
Absorbing heat.
Heat energy is absorbed.
Heat is
Absorbed.
absorbed during the chemical reaction. Okay. Examples. Photosynthesis. Next one. Decomposition reactions. Next. Next, any other reactions?
Sir, is the use of solar panels also a part of it? Like how solar panels use light energy and heat energy?
Yeah, solar panels we cannot take as an endothermic because it is absorbing the energy from the sunlight and still it is producing energy and giving to us, right? In other format.
Oh yeah, yes, sir.
We cannot take the solar panels as the endothermic or the exothermic.
Okay, sir.
So ionizing an atom.
Okay, we can say ionization enthalpy. Good. But again, reaction enthalpies are different. Sometimes if you remove the electron, the reaction will be more stable, right?
Yes, sir. Like the ionization energy.
Yeah, ionization energy means what? Energy required to remove an electron from the outermost shell.
Last shell.
But if you remove that electron only, the some elements will become more stable than previous.
Yes, sir.
Like sodium. Initially, you have only one electron in the outermost shell. If you remove that one electron from the outermost shell, the sodium plus one is more stable, right? Because of having octet configuration.
Yes, sir.
So you cannot say ionization enthalpies are always exothermic. Maybe first and second can also be the endothermic. Sorry, first one can be endothermic, second one can be the exothermic.
Okay, sir.
Okay. So just to find out some more examples for the next class on this topic, exothermic and the endothermic. Clear, everyone?
Yes, sir.
Yes, sir.
Okay. Next one, we'll go for the, this is the fourth or fifth one? Fourth one. Fifth one is the formation of precipitate. So everyone knows what is a precipitate, right?
Yes, sir.
Formation of precipitate. So when you're combining two reactants, it will use two other new products, but one of the product will be the insoluble solid in the given liquid. That is only the formation of precipitate. So already have taken the example before itself. Or if you want one more example, we'll take like this. Barium chloride plus
Sodium sulphate.
sodium sulphate.
Barium sulphate plus sodium chloride.
Barium sulphate plus sodium chloride. This is the 2Na. That's all. Everything is balanced. Okay. This is the precipitate. This is the aqueous. What about these two conditions?
Sir, aqueous. They are salt solution.
It should be compulsory aqueous only. Then only the precipitate formation will happen. Okay.
Yes, sir.
It should be aqueous. It also should be the aqueous. This is a precipitate formation. This is a white color one. Okay, these are the characteristics of the chemical reaction. So we can identify whether the given change is a chemical change or not with the help of any one of these 5 characteristics. So whenever the chemical changes happen, any one of these characteristics will occur, either change in temperature, evolution of the gas, change in color, change in state, formation of the precipitate. So any doubts in this?
No, sir.
No, sir.
Okay. So next one is a balancing concept. So till now what we studied is only the introduction part. Okay, now the main concept will start of this chapter, because if you take any competitive exam or any board exam, compulsory the question will be there on the balancing. So without balancing question, there will be not be a question paper at all. So balancing the chemical equations.
Okay, sir.
Now, which law will follow for the balancing the chemical equation?
So law of conservation of mass.
Will follow the law of conservation of mass. What is the law of conservation of mass?
So it states
Mass
that
can neither be
mass
created nor
cannot
be
be
Mass
destroyed
can neither be created
during
nor
the
be
chemical
destroyed.
reaction.
So first one is mass neither be created
Not destroyed in a chemical reaction.
nor be destroyed in a chemical reaction. Okay, next definition.
the product of sorry, the sum of masses on
So
reactant side.
the mass of reactants is equal to the mass of the products
Mass of reactants
is
Equal
equal
to
to the
sum
mass
of
of
mass of
products.
products.
is equal to mass of products. Next,
That's it.
So number of atoms in
very
the
good.
reactant side
The
is
number
equal
of
to number
atoms
of
in the
atoms
reactants
in
is
the
equal
product
to
side.
Very good. This is only the law of conservation of mass will follow in the balancing concept. The number of atoms of each element on the reactant side should be equal to
Number of atoms in the product side.
number of atoms of each element on the product side. So number of atoms of each element on reactant side is equal to number of atoms on each element on product side. Okay, this is the law which we use mostly in the balancing the given chemical reactions. So already I said the left side part of the arrow is called as an reactants, the right side part is called as an products, right? So if the equation is not balanced enough, it is called as an unbalanced chemical equation. Yes or no?
Yes, sir.
But what is the other name for the unbalanced chemical equation?
So skeletal equation.
Very good. So in the exam, sometimes they will mention the word like skeleton equation. So unbalanced chemical equation is also called as an
Skeleton equation.
skeleton equation. Now we can balance this unbalanced equation using the 3 different methods. One is the hit and trial, which is given in the textbook. The next one is the direct method. And the last one is the algebraic method. We can balance any given chemical reaction using these 3 methods: hit and trial, direct method, and the algebraic method. So if the one question will come for the exam for 5 marks now, we'll follow hit and trial, because it is having the total 7 different steps will be there. 6 to 7 steps will be there. Okay. But if the balancing concept will come for only 1 mark for each question, then we'll go for the direct method. That means we don't follow any steps, just we'll use some common sense. How many atoms are there on the reactant side and the product side, then we'll balance directly without going for any steps. The third one is the algebraic method. So whenever the given chemical reaction is somewhat complicated, we'll take certain coefficients on the before the reactant side and the before product side. Then we can solve that coefficients using the algebraic expressions. Then we'll get the final answer. That is the algebraic method. Okay. So out of the given three methods, my best one is the direct method. So if you learn the direct method now, we can solve the any given chemical equation within the seconds. Okay.
Also.
So anyways, you have to follow the NCERT syllabus also, right? So you have to first do the hit and trial method. Then I will teach you algebraic method. In the last, I will teach you direct method. Okay. So can anyone of you tell me what are the different steps are there in the hit and trial method?
Sorry, sir.
Hit and trial method steps.
Sir, first we will list the number of atoms on product and reactant side.
Okay. Step one, what will you write? We'll write here first, one by one. What will you write in the step one?
So like we'll write the total number of atom of each side of product and reactant on different sides.
Okay. Step two.
Then step two, will balance it.
Step two. Come on, remaining boys. Whether this topic is done in your school?
Yes.
No. What about the remaining?
So it has started.
Started. Okay. So totally have the 7 different steps are there. Okay. So what the first step is writing the given chemical equation in the word format. Writing the given chemical equation in the word format. So step one. Write the given chemical in word format. Suppose if I say iron reacting with the steam, it will form the iron oxide and the hydrogen. How you will write this one? In the word format you have to write, right? So iron plus steam will form iron 2,3 oxide and the hydrogen gas. So this is a given reaction you're writing in the word format. Next, step 2. What we will do? Convert the word equation into a symbol equation. Word equation into symbol equation. Okay. So what is the iron symbol? What happened? Strength got decreased. Any classes there after this?
No, sir.
No, sir.
Okay.
No, sir.
Now tell me what is the symbol for iron?
Fe.
Fe.
Fe. Steam.
H2O.
H2O only in the gaseous state. Nothing but steam is. Okay, it is in the solid state. Okay. Next, iron 2,3 oxide. That is Fe3O4 actually. plus hydrogen means hydrogen gas.
So what do you mean by 2, 3, sir? Either it will be 2 or 3, right?
Oxidation state.
Okay.
So if you take iron Fe2O4 now, it can actually this Fe3O4 does not exist independently. It will exist in the form of FeO and Fe2O3. So in the case of FeO, it is a +2 state. In the case of Fe2O3, it is a +3 state.
Okay. Yes.
Okay, sir.
That is what the meaning of iron 2,3 oxide.
Yes, sir.
Okay, what is the third step then?
Balance it.
Okay, in the second step itself,
First step, okay, sorry, sir. But actually, what we learn is we have to keep boxes for each equation. We will keep as a step 2, right, sir?
Okay, so in the step 2 itself, we will keep the boxes.
Yes.
So
Step 3, we will write the elements names and the numbers. How many atomic numbers are there? Sorry, not atomic numbers. How many atoms are there?
In the step 2, what we'll do now?
Step 3.
Okay. Step 2, what we'll do? Just we'll place the boxes around each chemical formula. Why we are placing boxes now? We should not disturb the number inside the boxes. Whatever the coefficients we are adding, we should not add inside the box. We should add only the outside the box. That's for that purpose only we are keeping the boxes in the step 2.
So once can I scroll up?
Mm-hmm.
Once can you go up, sir?
Sorry, I didn't understand.
So one can you go up, sir? Starting. Hello.
Your voice is not clear to me, guys.
Sir, can you go up, sir? 1 second.
Just keep a message to me. So third, go up. Okay. Now is it fine?
Yes, sir. Previously, I cannot see the step 1.
Okay. So step 3 is listing the number of atoms of different elements on the reactant side and the product side. That is the step 3. Listing the number of atoms on the different sides. That is the step 3. Can you scroll down?
Yes, sir.
Yes, sir.
So what are the different atoms are there? First, we'll write the elements. And next column, we'll write number of atoms on LHS and number of atoms on RHS. Now tell me what are the different elements are there here? Iron. How many iron atoms are there on the LHS?
1, sir.
1. On the RHS?
3.
3. Next one. Hydrogen. How many hydrogens are there?
2, sir.
2. 2 hydrogens are there. On the RHS also you have 2. Next, oxygen. How many oxygens are there?
1, sir.
1. What about the RHS?
4.
4. Now this is the first tabular column we will write by listing all the atoms and their numbers on the LHS side and the RHS side. Fine. Now this is the important step here. Out of these given numbers, 1, 2, 1, 3, 2, 4, which one is the highest? That we will select first. That element will select first and will balance that element first. Then the remaining elements will balance in the next step. Now tell me, out of these given numbers, which one is having the highest value?
Sir, oxygen.
Oxygen. Oxygen is having highest value, right?
Yes, sir.
So we'll balance first highest number of atoms. Okay. So step 4 is what? What is the step 4? Select the compound with maximum number of atoms to start balancing. Select the compound with maximum number of atoms to start balancing. Okay. So again, we draw one tabular column here. So atoms of oxygen, LHS, how many are there? RHS, how many are there? First, initially, how many are there? Initially, LHS, we have the one that is in the H2O. RHS, how many are there? 4. That is in what? Fe3O.
Fe3H4, sir.
Okay. Now, finally, how many are there? You have to balance on both the sides, right?
Yes, sir.
Okay. You want to balance on both the sides now?
Yes, sir.
How many oxygens you have to take on the LHS side? Multiply with the 4 only, right?
Yes.
Okay. Multiply with the 4. So what is the given reaction here? First, we'll write the given reaction. What is the given reaction actually? Fe plus H2O to give Fe3O4 plus H2. So you are multiplying the LHS side of water with the 4. Okay, just multiply with the 4. This is the updated equation now for us. Understanding?
Yes, sir.
Then what we can do for the remaining things?
Sir, 4 and H2 on the right side.
Now we got 4 H2 on the right side. So next we can balance the remaining all the elements. So this is step number 5. We'll do now WeXL or we'll do in next class.
We'll do now only, sir.
Will do now, sir.
Okay, good. So step number 5. Balance the remaining elements. So what are the remaining elements left here? Oxygen, we balance it. Next we'll balance the hydrogens and iron. Okay. So first we'll balance the hydrogens. Further we will draw one more box. Hydrogen, LHS, RHS. Initially, how many are there? Initially, how many hydrogens are there in this equation?
Sir, 2 and 2.
How come 2? We added 4 right before here.
Yes, sir.
So 4 to the 8 right now.
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir. So
8,
we're supposed to
8
keep
and 2.
another 4 beside
4,
H2.
2. Next RHS. Only 2
2.
H2. Clear? Now
Yes,
tell
sir.
me how much you have to add balance, how much, what factor you have to multiply? This is 8 as usual, but this one have to
4,
multiply
sir.
with 4 factor, right? So entire equation have to multiply with the 4 factor. So what is the previous equation we got here? Fe plus H2O. This is the 4 produce Fe3O4 plus. Then we have multiplied with the 4. Yes, sir. Now this is the second updated equation we got. Understand the step?
Yes, sir.
Next one, what is there left? Finally,
Fe.
iron is left. Now again, one more tabular column. So that's all drawing tabular columns only in this method. Sorry, iron, right? So once we study the direct method now, we'll have we won't do this method again. So in the case of iron, so initial how many are there?
1 and 3.
Fe, okay, and 3 in the Fe3O4. So balance is what you'll take.
3 in the LHS.
Multiply with the 3 is also 3. What is the equation part finally? What equation will get? Fe, you have to multiply with the
3.
plus 4, you have to multiply with the H2O. This rise to Fe3O4 plus 4 H2. Yes, sir. Now this is the finally balanced chemical equation. Check it. Whether
Yes.
the number of atoms will be same on both the sides.
Yes, sir.
Is it the same?
Yes, sir.
Now what is the step 6? Again, check number of atoms on both the sides.
Sir, is it compulsory, sir? Step
Yeah, you have
6.
to check it. Compulsory, you have to check it. Then only we will get to know, right? Whether the
Yes,
number of
sir.
atoms is same or not. So again with the traveler column. Elements. LHS. RHS. So iron. Next. Hydrogen. Next. Oxygen. How many are there?
3, 3. Iron 3, 3.
3, 3.
Then 8, 8.
8, 8.
Then 4, 4.
4.
4.
4. So these are the number of atoms on the both the sides. So it is a balanced chemical equation. So what is the step 7? Writing the given equation without the words, without the brackets. That is what 3 Fe plus 4 H2O will form Fe3O4 plus 4 H2. So this is a complete equation we are writing with the without the boxes and along with the states.
Yes, sir.
This is in the gaseous state, this is in the solid, this is in the gas. That's all the balancing concept using the hit and trial method. So these are the 7 steps you have to follow for the balancing. Understand or any doubts?
No doubts.
Understood, sir.
When we started this topic, 21 people is there. Now when we end this topic, 13 people are there. Nice. Right?